In the darkness, an object moves, and only one telescope in Chile captures it on July 1st, 2025. At first glance, nothing seems unusual. However, 24 hours later, astronomers realize they have discovered something incredible. This object moves at a speed of 220 kilometers, 472 meters per hour. Too fast to belong to our system, too fast to orbit our sun. He came from another star, and Atlas became the third confirmed visitor from outside our solar system. The first was Oumuamua in 2017, the second was Borisov in 2019. Both left more questions than answers. But 3 and Atlas are different. It is larger, brighter, and more active. Its chemical composition breaks all known rules about natural objects in space. This scenario is based on factual data and uses sources from the X-shooter spectroscopic study conducted at the Very Large Telescope of the European Southern Observatory, published by Rohan Rahat-Kaunkar and his colleagues in August 2025. Also, the observational data from the Hubble telescope and the James Webb Space Telescope, published by Martin Cordinera's team at the Catholic University of America. Now, let's return to the information. The Atlas Research Telescope in Rio Hurtado discovered 3 objects at a distance of 4.5 astronomical units from the Sun, 4.5 times farther than Earth. At such a distance, comets should be frozen, dead. But 3 and Atlas were already showing activity, already glowing, already challenging the laws of physics. The Hubble telescope took notice of the object on July 21st. The image revealed what astronomers had never seen before. Instead of a tail pointing away from the sun like an ordinary comet, 3 and Atlas had an anti-tail. Light scattered towards the sun, not away from it. David Jewett from the University of California, Los Angeles called this a precedent on August 27, 2025. The Gemini South telescope in Chile captured the first clear image of Comet Tri and Atlas, developing a full tail. The coma now spans 120 degrees in the sky, 56,000 kilometers of gas and shining dust. But then the story takes a strange turn. The James Webb Space Telescope directed its infrared eye at Comet Atlas on August 6th. What it discovered rewrote the chemistry of interstellar objects. The coma contained carbon dioxide, and a lot of it, 8 parts carbon dioxide to 1 part water. This is the highest ratio ever recorded for comets. Martin Cordinier from the Catholic University of America led the observations. His team found that carbon dioxide made up 95% of the gas mass, while water only accounted for 5%. No comet in our solar system behaves like this. Water is the basis of every known comet, triggering their activity and creating tails. However, 3 and Atlas operate on carbon dioxide and the ocean, which sublimates directly from solid to gas, bypassing the melting stage. The SPRX Space Observatory confirmed the discoveries of the Webb telescope from August 7th to 15th. A cloud of carbon dioxide stretches around 3, and Atlas for 348,000 kilometers into space, almost the distance from Earth to the Moon, all in carbon dioxide, with no water or carbon monoxide, just a pure mist of carbon dioxide enveloping an object from another star. But carbon dioxide was only the beginning. A very large telescope in Chile began observations of Comet 3 and Atlas with its spectrograph on July 4th. What happened next shattered 40 years of scientific understanding of comets. The telescope recorded atomic vapor of nickel emanating from 3 and Atlas. The emission of nickel is not an unusual phenomenon. Many comets emit nickel when solar heat breaks down metal grains. But 3 and Atlas emitted nickel without iron. Not a trace of iron anywhere. In 4 decades of studying comets, no astronomer has ever observed nickel without iron. Nickel and iron are cosmic twins. They form together in the nuclear reactions of supernova explosions. They are found together in every asteroid, every meteorite, every particle of cosmic dust ever analyzed. Their separation is impossible in nature. Rohan Rajatakaunkar led a team of a very large telescope. His measurements showed that 3 and Atlas ejects 4.6 grams of nickel per second by August 21st. The emission rate sharply increased as the comet approached the Sun, following a gradual law with an index of minus 8.43. Nothing natural demonstrates such a pattern. Another discovery occurred on August 22nd. Cyanide gas. 3 and Atlas were emitting cyanide at a rate of 17.6 grams per second. The emission rate increased even more rapidly than that of nickel, with a power law index of minus 9.38. Thomas Puzia from the Pontifical Catholic University of Chile analyzed the data. He called it the opening of a door to a completely new world of chemistry. Nickel without iron. industrial levels of cyanide. The ratio of carbon dioxide to water is 8:1. These signs indicate unknown chemistry in natural cosmic objects. On Earth, nickel without iron is found during the industrial processing of nickel alloys. Cyanide coatings of nickel protect metals from corrosion. But this is space, billions of kilometers beyond the nearest factory. The expanding coma of 3 and Atlas tells a story recorded in molecules. As the object approaches the sun, solar heat causes sublimation. Carbon dioxide ice turns directly into gas. This gas carries tiny dust particles less than 1 micrometer in diameter. These particles scatter sunlight, creating its visibility. But the chemistry here does not meet expectations. The proportions are wrong. The behavior is also incorrect. Estefan and Milan from NASA. Goddard offered an explanation. 3 and Atlas have drifted in interstellar space for billions of years. Cosmic rays have bombarded its surface. High-energy particles could stitch the outer layers, creating exotic ices. This transformed the ordinary chemistry of the comet into something unrecognizable. A stitched shell of repurposed materials surrounds the ancient core. However, the theory of the stitched shell does not explain nickel without iron. The impact of cosmic rays would affect both metals equally. There must be something else separating them, something that disrupts the fundamental rules of cosmic chemistry. David Joey from the University of California, Los Angeles, evaluated the core sizes using data from the Hubble telescope. Its diameter ranges from 440 meters to 5.5 kilometers. This is small for such a bright object. The brightness comes from the expanding coma made of gases and dust reflecting sunlight for hundreds of thousands of kilometers. But where is the tail? Ordinary comets develop noticeable tails of dust when solar radiation pressure pushes particles away from the nucleus. 3 and Atlas do not show such a tail in Hubble images. Light scatters evenly in all directions, forming a sphere instead of a droplet. Another violation of comet physics. September 7, 2025. Michael Yeager and Gerald Raymond are taking new photos, where Tri and Atlas change color. The object, previously appearing reddish in all previous observations, now glows with green hues. The color change coincides with the explosive increase in cyanide production, detected using the Very Large Telescope. Cyanide molecules emit a characteristic green light when activated by solar ultraviolet radiation. This moment is important. 3 and Atlas passed closer to Mars on October 3rd. NASA's orbital probe photographed the object with a resolution of 30 kilometers. These images will reveal whether the brightness comes from a giant core or from diffuse dust clouds. Any of these answers calls into question our understanding of interstellar objects. 3 and Atlas reach perihelion on October 29th, 2025, at a distance of 1.3 astronomical units from the Sun, right inside Mars's orbit. Close enough for maximum solar heating. Close enough to expel the remaining volatile substances. Close enough to reveal what is hidden beneath the expanding coma. But the window of opportunity is closing. After perihelion, Tri and Atlas quickly depart on their hyperbolic trajectory, back into the vacuum between the stars, back to where they came from billions of years ago. This is humanity's only chance to closely study an active interstellar comet. November brings the final opportunity. When Tri and Atlas emerge from behind the sun, Bryce Bowling from Eureka Scientific organizes a new observation session with the Hemen and Norte telescope. Students and scientists work together to capture the latest images of our mysterious visitor. They strive to measure what remains after the sun has shed its outer layers. The expanding coma shows that Tri and Atlas are an unprecedented phenomenon. It's not quite a comet and not quite an asteroid. Something in between. Something that transports chemical elements from another star system. Chemistry that challenges our understanding of planet formation around distant stars. 8.0 plus or minus 1.0. This is the ratio of carbon dioxide to water, measured by the Hubble telescope. 4.4 sigma above average among known comets. A statistical impossibility. If Tri and Atlas formed like objects in our solar system, then they came from another place. A place where carbon dioxide ice may prevail over water ice. The line of carbon dioxide ice. It is here that Martin Kordener's team believes that Tri and Atlas formed, far from their parent star, in the cold outer regions where carbon dioxide freezes before water. A zone that almost doesn't exist in our solar system but may be widespread around other stars, with stars of varying mass, brightness, and planetary system architecture. 3 and Atlas carry primordial materials from the era of galaxy formation, potentially between 3 and 11 billion years old, older than our solar system, older than Earth, a messenger of time, when the galaxy had different chemical abundances, different stellar populations, and different conditions for forming planetary systems. The production speed of nickel increases with a power of 8.43 as Tri and Atlas approach the Sun. No known physical process shows such a pronounced dependence. Natural sublimation follows smoother curves. Thermal desorption reveals different patterns. Something else affects the release of metal from Tri and Atlas. Nickel, carbonyl. This is Thomas Puglia's hypothesis. A volatile organometallic compound that easily decomposes under sunlight's ultraviolet rays, releasing pure nickel atoms and carbon monoxide. This compound exists in industrial chemistry and forms during certain metallurgical processes. But how did it end up on an interstellar comet? A very large telescope did not detect iron emission lines in any spectrum range of Tri and Atlas, although iron should be there. Its absence suggests exotic chemistry or instrumental limitations. Future observations with the Space Telescope. The James Webb Telescope can detect iron in infrared wavelengths inaccessible to ground-based telescopes. He can also confirm that the object called 3 and Atlas indeed disrupts the correlation defining natural celestial bodies. David Groves from the University of California, Santa Barbara suggested listening for technological signals from Tri and Atlas, as well as monitoring radio frequencies for artificial signals. This statement sparked discussions among astronomers. Some called it premature, while others noted the unprecedented chemistry and impossible radiation curves violating fundamental laws of physics. Avi Loeb from Harvard noted alarming coincidences. 3 and Atlas are moving along a trajectory aligned with the plane of the ecliptic of our solar system, and the probability of this is 0.1%. He arrived 80 years after humanity began transmitting radio signals, and 80 years after the first nuclear test explosion, as if something noticed our technological progress and decided to investigate it. However, the evidence points both ways. 3 and Atlas demand clear cometary activity and exhibit behavior characteristic of an object heated by solar radiation. However, chemistry remains impossible. Metallic emissions contradict physics, and the dominance of carbon dioxide disrupts the rules of comets. September 4th, 2025. 3 and Atlas passes by NASA's Psyche spacecraft heading towards the metallic asteroid Psyche. He is close enough for observation and detailed measurement, but Psyche's tools are not designed for comet analysis, and this opportunity slips away. October will bring a critically important test. Several spacecraft positioned throughout the inner solar system will observe Tri and Atlas during their closest approach to the Sun. Telescopes like Hubble, James Webb, TESS, SWIFT, the Mars Orbiter, Curiosity rover, Perseverance rover, Europa Clipper, and Parker solar probes will work together to unravel the mystery of our most enigmatic interstellar visitor. Comet 3 and Atlas grow larger as they approach perihelion, forming a vast mass of dust and exotic chemicals. A small cloud of carbon dioxide now spans nearly 500,000 kilometers, more than the distance from Earth to the Moon. This occurs due to the sublimation of dry ice rather than regular water ice. In the coma, there is water ice, which the James Webb Telescope detected in the form of tiny crystals less than 1 micrometer in size, but these particles sublimate far from the nucleus, at distances of 4 to 10,000 kilometers, ejected as a result of carbon dioxide degassing, rather than their own sublimation. Another investment in comet behavior that goes beyond the ordinary. The mystery deepens with each new observation. 3 and Atlas question existing classifications. Too active to be an asteroid. Too chemically unusual for a standard comet. Too ancient for most formation scenarios. Too fast for origin in our solar system. It occupies a unique category. Interstellar objects like Tri and Atlas provide us with the only direct samples of materials from other star systems, chemical messengers that carry information about planet formation, distant solar systems, stellar evolution in various galactic conditions, and the diversity of worlds beyond our cosmic neighborhood. But Tri and Atlas refuse to fit into our models. Its chemistry indicates formation under conditions different from anything in our solar system, perhaps around a carbon star, perhaps in a system with unusual ice line locations, perhaps through processes we do not understand. Observations from the Very Large Telescope ended on August 21st, when Tri and Atlas approached the Sun and became invisible from the night sky of Chile. The latest measurements showed a nickel level exceeding 22.67 on the logarithmic scale, almost 4 grams per second of pure metallic vapor rushing into space. The cyanide emission was increasing even faster. These production rates placed Tri and Atlas among the most active objects ever observed. more active than many comets much closer to the Sun, driven by volatile substances that shouldn't exist in such quantities. Following the laws of degree that describe no known natural process, November will bring the final chapter. When Tri and Atlas emerge from the solar convention, astronomers expect dramatic changes. Most of the carbon dioxide should disappear. Water may take on the role of the main volatile substance. The chemical composition may change to a more familiar behavior for comets or reveal new paradoxes. Karen Mitch, from the University of Hawaii, leads an international observation campaign. Her team uses public discussion sessions to engage students in critical observations, real-time scientific work, discoveries happening before their eyes. A new generation of astronomers studies interstellar chemistry from the most mysterious object in the solar system. The expanding coma of 3 in Atlas tells us that interstellar space contains objects unlike anything in our solar system. Chemistry formed in various stellar environments, physics operating under different conditions, processes that challenge our understanding of how planetary systems form and evolve. But it also tells us something greater, something recorded in the stark laws of metal emission degrees, in the impossible separation of nickel, iron. In the fog of carbon dioxide that defies the physics of comets, 3 and Atlas may become the most important objects ever to enter our solar system in history. The perihelion will occur on October 29, 2025. 3 and Atlas will reach their closest approach to the Sun at a distance of 200,768,400 kilometers. Time of maximum heating, maximum activity, maximum exposure. After this moment, our interstellar guest will begin its return to the void, back into the darkness between the stars, back to where he may have come from billions of years ago. The expanding coma will eventually dissolve. Exotic chemistry will vanish as volatile substances are depleted by solar radiation. The mystery will remain. We witnessed the demise of an ancient comet from another star. We saw something completely different, something that questions our assumptions about what exists in the universe beyond our small corner of the galaxy. Observations from Earth in the Atacama Desert in Chile recorded how Tri and Atlas changed color from red to green, coinciding with a sudden increase in cyanide production in early September. The color change became noticeable to amateur astronomers worldwide, an interstellar object transforming before our eyes, revealing chemistry written in light through the electromagnetic spectrum. Final measurements will be obtained from space telescopes, unaffected by atmospheric interference. The James Webb Space Telescope can detect molecular signatures invisible to Earth-based instruments. Hubble can resolve structural details smaller than any terrestrial telescope. Together, they can unravel the mystery of Tri and Atlas before they disappear forever. Or they can deepen this mystery by adding new impossibilities to an already impossible object, challenging our understanding of what is possible in the universe and our assumptions about the chemistry of interstellar space, about the variety of objects floating between the stars, what might be there waiting to be discovered. The expanding comas of Tri and Atlas convey messages written in molecular calligraphy. Carbon dioxide instead of water, nickel without iron, cyanide on an industrial level, chemistry indicating formation conditions unlike anything in our solar system, on stellar environments that we can hardly imagine, on processes operating on scales of space and time beyond human experience.